All right, first question, it says solve. I observe that it's an inequality, but I'm gonna treat it like an equation. I'm just gonna put my line at my equal sign, right? This is not an equal sign, that's okay. I'm gonna get x by itself, so I'm gonna cover the side without the x, and I realize I need to add 3 to both sides, right? Always deal with addition and subtraction first. I'm gonna bring down my sign. Let me leave myself a little bit more room here. Okay, bring down my sign. 27 plus 3 is 30. Now, here x is being multiplied by -5, so I'm gonna go ahead and divide by -5. Okay, so I'm gonna bring down x is now by itself. Here I divided by a negative, right? I divided by a negative, so I know that I'm gonna flip the inequality sign. So here I had a greater than or equal to, I'm gonna flip it to a less than or equal to, and then positive divided by a negative is a negative, 30 divided by 5 is 6. And there it is. Here this says solve for y. Anytime I'm asked to solve, I'm gonna go ahead and put a line at the equal sign, and I'm looking to now get y by itself. Okay, I want it on the left. I observe that in this case, I have more than one letter, so I'm just looking to get y by itself. I'm gonna first move this term with the x over to the right side of the equation. So that gives me 3y. These are not like terms, so I'm not combining. I'm just gonna bring down 6x and then plus 15. And then since I want y by itself, I'm gonna go ahead and divide by 3, divide by 3, divide by 3 all the way through. 6 divided by 3 is 2, so that's 2x. And then 15 divided by 3 is 5. Okay, and this is done. Now notice, had this been, I have to be careful of signs, right? Had this been like, say, a negative divided by a positive, that would have been a negative. Had it been something like 3 divided by 4, which would have been a decimal, I would have kept it as a fraction. But in this case, 6 divided by 3 is just 2. Translate this into an algebraic expression. Okay, right away it's telling me I don't need an equal sign. Okay, it says use x to represent a number. So a number is going to be x. Okay, increased by. Increased by. Remember, this means gets bigger. So I'm going to take this number and I'm going to increase it. I'm going to add 2. Okay, so my expression is just x plus 2. I'm taking a number and I'm increasing it by 2. Translate this into an algebraic equation. Okay, this tells me already there's going to be an equal sign. Look, let's look. I already know there's going to be an equal sign. Let's find it. Here it is equivalent to. Okay, that's my equal sign. So the difference of a number and 5 is equivalent to 8. Let's do the easy side first. Okay, difference. I know that the word difference means subtraction. The difference of a number and 5. So the difference of a number, okay, difference, and 5 is equivalent to 8. This says solve for x. So I'm going to draw a line. I want x by itself. I'm going to start by, right, I deal with addition and subtraction first. I'm going to get rid of the b. This is a times x equals c plus b. Now I need x being multiplied by a, so I'm going to go ahead and divide by a. I get x equals, okay, now I want the c plus b to happen first, so I'm going to do c plus b divided by a. Okay. Now I'm graphing. I'm looking at the sign. The two questions I'm asking myself are open or closed circle. Okay, that's the first question I ask myself. And the next question I ask myself, am I shading left or right? Okay, so here I look, this says x is greater than or equal to, So if it can be equal to -1, I'm going to put a closed circle. Okay, this is closed. And then this says greater than. How do I know? Because the mouth is open towards the x. So I know the mouth is open towards the larger value. So what I want to say is that x can be the values larger than -1. Which way are the values larger? Oh, this way, right? These are bigger numbers than -1. 1 and 2 and 3 and 4 and 5 and 6, those are all bigger numbers than -1. So I'm going to shade it, make it nice and clear which way you're shading it. Okay. Here this says x is less than. How do I know it's less than? Because the mouth is open towards the 3. So x is less than 3. That means it can't be equal to 3. It has to be less than 3. So I'm going to put a nice open circle, make it really clear that it's open. And then the numbers that are less than 3 are here. 2, 1, 0, negative numbers, right? These are all numbers that are less than 3. So we're going to shade this direction. And notice what I do. I usually just make a line like a little bit above the line and then just kind of shade on top of it like this. Okay. All right, we have a proportion. So first we cross multiply. Okay, and then once we cross multiply, we can just go ahead and solve using all our solving skills. Okay, so cross multiplying looks like this. Okay, so it's 2 times 20 equals 10 times x minus 1. It doesn't matter the order, like I could put 2 times 20 on this side or this side. I like my x on the left, so I'm gonna go ahead and put the 10 times the x minus 1 on the left and the 2 times 20 on the right. Then I'm multiplying. 10 times x is 10x. 10 times negative 1 is negative 10. 2 times 20 is 40. I'm going to go ahead and solve, right? Here's my equal sign. I'm going to deal with my addition and subtraction first. And I get x equals 5. Done. Match each problem with the solution path for that problem. Put the letter of the solution path on the line. Okay, so here are my options. First, get all variables to one side, then solve. Use inverse operations to get x by itself, right? That's what solve means. And then I notice I see another solve down here. Okay, so right away when I see solve, I know like I have to be looking for an equal sign to solve, right? Like if I have an equation, I can solve. If I don't have an equation, I can't solve. So let's actually just go ahead and start with the 2 equations. So right, like I have this is going to be an equation, this is going to be an equation. And look, I find my equal signs and my equal signs. Okay, so this one says just solve. Use inverse operations to get x by itself. And I'm looking and I see like this one actually has variables on both sides, right? So here I would actually have to go ahead and get the variables to one side first. I'd have to do like, you know, minus 2x, get all the variables to one side, and then I'd be ready to solve. So this one with an equal sign and variables on both sides, that is going to require me to have this solution path. First, get all the variables to one side, then solve. Whereas here, I already have all the variables on one side, so I'm ready to just go ahead and solve. Okay, so remember, solve is for equations. And now use order of operations to simplify. This is where I'm just looking for just numbers only and no variables, no equal signs. I'm just have numbers. Whereas here, this is where I'm looking for, I have numbers and variables, because this is where I'm not going to be able to just fully use order of operations. I'm going to have to just use my strategies of distributing and combining like terms. So let's take a look. So I'm looking for B. I'm looking for numbers only, and I just check carefully here, and I don't see any variables here. So I'm pretty sure this is going to be my order of operations. And let's just check right here. Oh, I see I do have a variable, right? So here, what would I do first, right? I'd like, you can like kind of do it for yourself if that sort of helps you think about it, right? This would be like this. And then I would combine my like terms. So here is where I distribute and I combine like terms, and that's C. Okay, but you don't have to do this, right? You can just kind of do that if it sort of helps you think about it. All right.